Hello, everybody. Can you hear me?
Yep, we can hear you.
Okay. All right. Yeah. So one brief, announcement. So yeah, this year, and then we have some, specific the topic for the project. So we're gonna do some kind of interesting the project, something like image machine learning, and then especially it is called in object detection. And then well, using that the project, and then you are supposed to participate in the hackathon on July 26th at the USC campus. And don't be scared. So we're gonna provide all the guidelines, and then as long as you know some basic Python, and then well, understanding some basic AI and machine learning code, and then it's not that difficult. So after the class, and then I'm gonna send some link for the hackathon webpage, and then you are supposed to register for the hackathon, and then we will send some basic information about the hackathon, about dataset and the tutorials, and also next following the lectures, and yeah, you're gonna learn about how to perform the object detection. Okay, that was my brief announcement. Any questions about that? Okay, then yeah, Min-sam, can you start? Thank you.
Okay. Right. Hello, everyone. Um, Good evening. This is morning here. And then, so any questions from last class? No? Okay. So today, we are going to have a look at one of the data science project example. And the link to the Kaggle project is in our lecture 4 slide, posted in our Google Drive. Um, Briefly showing. Yeah, so the lecture 4 data project example. And then if you go and have a look at the next page, we have included the link to the Kaggle project and then the data set. So if you go ahead and then go into the link, it will guide you to the crime analysis project that someone has done for us. So we're gonna have a look at it and then go one by one and see how it analyzed the Los Angeles crime. So I would recommend that you guys actually download this. So you can download through here. You can add it in Colab, but um, like I said last lecture, the Colab has some issue, not issues, but you need to know how to download your data in the right place. So it's kind of a little bit more complex. So I would recommend you to download the code and then open it up in your Jupyter notebook. And then if you go into your input, it also has the data set. So if you download this also, it will download and then you can download the code. So I'll give you a brief moment to do those. Download it and then put it in the same folder. And then let me know if you have any like issues opening it up.
Oh, can you explain that one more time just so that we can hear it again?
Okay, so if you go into the link, this is your page. If you click on the three dots over here, am I sharing the right screen?
Yes.
Yeah. Okay, so if you click onto the three dots on your right upper side, you can download the code. And then for the data set, you can go into the input and then click download here. And then you will open it, you'll get your zip folder, unzip it, and then create lecture 4 folder and then put it in the same folder so that your path is easy for you to do a pathing to the data set. Please let me know if you guys are done with those, and then we can start with it. I think you might have to log in if you want to download the data set. For me, I just already did, so use your Google account. All right, was everyone successful? Okay. See one person good with it. How about everyone else? Mhm. So Christina shared us the link in the chat. So if you have trouble finding it, you can use that link. Okay, I need answers from other students. Is everyone done with it or Still working on it. Okay, good. All right. You can chat directly to Christina. She can help you if you have trouble opening it up. And then I'll get started with it. Okay, can everyone see my screen? So I'm using the Visual Studio. It's basically the same thing with the Jupyter Notebook. So only difference is what interface you're using, and most of it the same. So you can do exactly the same way with the Jupyter Notebook too. I downloaded it, and then I have my data set in the same folder. So the version 1 introduction, Los Angeles had been known to be a crime-ridden area. We're interested in gauging the types of crime, where they occur, how crime occurrence and reporting are over time, and the status of each crime. The data set is from data.gov and covers 2012 to 2016. And I just had a look at it in the Kaggle. They had all bunch of years of crime data. So if you're interested in the recent ones, you're more than welcome to try it yourself. Here, they did it from 2012 to 2016. So loading the data, first we will load the data for consumption. They started with importing the important ones, pandas, numpy, and matplotlib, plt. I changed my path to this because the data set is in the same folder, and then I didn't change it. So you guys also needs to change the path to the right one. So the data name is right here for me. Then we read the CSV through pd.read CSV. Okay, and then this first line is the code that this person has written, the total number of crimes in the data set, and with a format, it gave the length of crime data. So this is kind of an old way. Now we use the F string. So in the same way, we use the F string, and then we start with the text that we want. And then with a curly bracket, we put the variable that we want to call inside the curly bracket, so that we don't have to go through this dot format. And then it will, if I run this, it will print out the same thing. So although you might not be using this, it's good to know what this is doing. Just you know that this is the old way, so you can understand what it does. And then crime data.head, we start by looking at how the data actually looks like. So date reported, I guess, DR number, dates occurred, time occurred, area name, road, crime code, description, I guess, status, descending, description, location, cross streets, and location 1. So there's the latitude and longitude. Okay. Going over listing crime types. We would like to break down all of the crimes that occurred in the 4-year period. So the variable name is crime by type. And then from the crime data here, we want to have a look at the crime description column. So over here, and then we do the value count. So the result is like this. Traffic, driver number, very simple assault, vehicle stolen, burglary from vehicle. Big number of crimes happened in Los Angeles. Okay. Is everything good so far? All right. So we take note that traffic, battery, and assault are the most common crimes in Los Angeles. Now we want to graph the total number of crimes by year. I decided to add a column that only graphs the year. This will allow us to make it easier to graph and analyze the data. So crime data, year, PD.series, crime data, date reported. Let's have a look at the date reported here. Okay, so it goes by month, date, and year. So this person wanted only the years. So he's replacing it. Or is he creating a new one? Yeah, so he's creating a new column. With crime data, date reported, and then dot string, -4 colon. Does anyone know what this means? -4 to column? So what this does is it's trying to read the last 4 number. I mean, in this case, the text. So this person wanted only the year. So it goes from 1, 2, 3, 4. So this person is trying to read the 4 digits of the state. So it's good to know that the negative in this case is trying to read from the right side. And if it's a positive number, then it will be reading from the left side. And the index, it keeps the same index as our original data set. Okay, so crime by year, crime data, year, value count. So it's now counting the value of how many crimes happened for each year. Crime data year is doing the value count. It doesn't want to sort anything. And then it will want to sort the index. And then the crime year dot plot. What kind of plot? They want to do the line plot. So it might be trying to zoom in, but so how do I change the background? It may be a little bit hard to see here, but the x-axis has the years, 2012, 2013, 2014, 15, and 16. On the left side, it has the number. So we can assume that the left side is the y-axis is the number of crimes. So it has been increasing up until 2014 and then got a steep decrease up until 2016. From the data, 2014 was considered the worst year for crime. Let's look at the 10 most common crimes that occurred during the year. So what this is trying to do is doing the for loop and then crime by year dot keys. So this might get you confused. So why is this using the key? Oh, okay. So now you can see better. 2012, 13, 14, 15, and 16. So 14 was the highest. So this person is trying to do the keys. So we can try to see what the crime by year looks like. In this case, here it did the value count. So we can it's not defined. Crime by year. So it has the key and the value. So what this trying to do is to get the keys, the years from crime by year, and then do the for loop. So it's repeating. Crime by year equals to crime data year. So this is the real equals to year. And then crime code, description, that value count. So last time it was -4, but this time is from all the 1 up until the 10ths. So from the top, it's going to read up until 10. And then crime year dot plot, what kind? Now it was to the bar chart, and the title is crimes in plus year. So for each year, it's trying to create the top 10, the 10 most common crimes that occurred during the year. So crime data year was the column that this person created over here. So it's trying to read the ones that has the same year 1 by 1. So from 2012, get the rows that has the 2012, and then get the data to the description. So it now then counts the value and then get the top 10. So for crimes in 2012, traffic, battery, theft plan, pity, burglary, and so on. So we can have a look at what kind of crimes here. So the interesting part here was that it reached its peak at year 2014, and then it slowly declined. So my guess from this idea is that maybe the number of like the top 10 doesn't really change up until 2014, maybe kept the same way. And then it started to, something must have started to change and then gave a big decline. So it's kind of fun and meaningful to think beforehand. So like for the reasons. So we're trying to find, we're doing the analysis of this data. So trying to think of the reason why this is happening so that you can do a better analysis of it. Sometimes the numbers here doesn't really show the reasons, so it's good for you to trying to keep digging into it. So traffic drive, let's have a look at 2013, 14, traffic drive, almost the same. Up until burglary from vehicle. It decreased a little bit. Became like 6th place here. It was the 4th place here, but not much of a difference. Vehicle stolen, theft of identity, same. Spousal abuse, still on top. Vandalism is still here, and then vandalism, felony. I guess a little bit changes in the vandalisms, but felony here, and then misdemeanor. Yep, they're both here. Okay, so let's look at them here in 2015. So traffic drive is still the top, and there was a big changes in this number. So it was over 40,000. Now it's below 40,000. Battery, simple assault, theft, plane here, vehicle stolen. Became the top third. Burglary here too. Felony. Spouse abuse was there. Burglary from vehicle, burglary. I guess I was wrong. That the type of crime didn't really change. Only thing that came up was assault with deadly weapon. And so this type vandalism has disappeared. Maybe it's still in the 11th place, but we only look at the top 10. So kind of scary that the assault with deadly weapon has increased a lot from here to there. But the biggest change was here, traffic drive. I guess from here to there, about 10,000. A big leap there. Second, yeah, decrease in overall number of crimes. But this looks a little bit different. Crimes in 2016. Now the vehicle stolen has gained its top place. Very simple assault, burglary from vehicle. Okay. Spousal abuse is still there. Identity is there. So deadly weapon is there. Theft from motor vehicle is still here. Okay. All right. So maybe there has been changes in the data, but let's look at what this person observed. So based off the data, we observed the following thing. Until 2016, the traffic drive number was, hold on, I lost the page. Was the most common crime in Los Angeles. Through the years, a simple assault battery remained as the second most common crime. The following crimes have remained common throughout the years: burglary, theft, identity, stole vehicles, vandalism, and spouse abuse. Okay. It's kind of weird that the biggest number just suddenly disappeared, but this person didn't really didn't take that seriously. Okay, so listing the crime areas. Next, we want to take note of which areas are most affected by crime. The crime data, area.name, value count, same. Now we want to find which area are the most affected. So 77th Street, Southwest, Hollywood, okay. Hollywood has the high crime rate. Pacific, Southeast, Mission, Venice, and all the stuff. 77th Street, I guess where that is. We take note that 77th Street is the most crime-plagued area in Los Angeles. In fact, if you Google map 77th Street, Los Angeles, the nearest police station is called the 77th Street Police Station. Yelping the place shows 2 stars. Next, I want to graph the 10 most common crimes in each area. Okay, so this looks kind of complicated. Let's have a look at one by one. The crime by area, crime data, area.name, value counts, and the sort index. So it's creating a new one. Crime common type, we assign it with a curly bracket. So that means this is a dictionary. It's gonna have key and values. For area, in crime by area.keys. Okay, so what this does is the same with the one up here. Not here. Yeah. So crime by year. We have can we have a look at, yep, here, crime by year. What it did was key and value. So same over here. It's gonna have a same format. What it would have, I don't know, but we can double check. So if I just copy and call it crime by year area, it's gonna have here PM value, the same one on the top over there. So the keys will be the area, and then it's gonna do the for loop again. Same thing with the year. It did the same thing, crime area, crime data, So on the 77th Street first, I want to get the crime description. I want to do the value count and get the top 10. So all up until the 10. So for crime type, in crime area.keys, because you did the value count over here, it's gonna have a same format as this. So this for loop is gonna have the area and the value count. And I mean the crime description, the which crime, and the value count, the key and value. So it's gonna read the keys in this area, the top 10 crime description. So I'm just going one by one. On the 77th Street, which crimes are there? If not, crime type in crime common type. If this is not in this dictionary, we're gonna put it in there, crime common type. Else, we want to append the area into the crime type of that specific crime type. Okay. Does this sound understandable to you guys? Any questions so far? Nope. Okay. All right. So, and then now we want to the plot each street. Then you want to show. Let's try to run it. Okay. 77th Street. Traffic drive number was the highest. It was the biggest. I guess. The types are what we have seen in our previous analysis by the year analysis. Looks pretty much the same. Although the order has changed a little bit, we can see the types, the description that we commonly seen in those. Devonshire, pretty much the same. Foothill, also same. Nothing really interesting over here. They look pretty much the same. Okay, let's see what this person analyzed as a result. So it did something one more time. Additionally, I want to create a table representing the most common crimes for each city. Okay. So it did the np.array. So the reason why this person did the array was to create a data frame. So false for I in list common type keys. So what this person did was creating a, let me mm, oh, my. So this person created a dictionary over here. So going back to the crime by type, tab keys, false for I in list here. Let's have a closer look because this looks complicated. Now it's gonna do false for I in list. So you're gonna put all the falses here. And then this one for J in list of crimes. So if this looks a little bit complicated for you, then you might want to cut them and then do step by step. Crime types, okay. If you want to go for the list, okay, that's list. False for I. Okay. For J. And then let's have a look what this does. Okay. Yeah. So it created all these falses because false for that. And then it put this whole list into each list and this keys. Now it created all the falses. Now we want to look at, so it's kind of creating a slot for each crime types and common types so that now it can create it into the data frame. Now it has all these slots we can assume. And then now it's gonna replace it with a true. If so for crimes in common type and for cities in the crime type, common type, if there's a common type for the crime, the traffic drive, and the cities in 77th Street, then we're gonna put true. If it's common, if the traffic drive number is common in 77th Street, then we're gonna put true. If it was not common, then we're gonna put the central, something like this, we're gonna put a false. So now we can see why this person has created a separate dictionary for crime common type. And then in this way, we can have an easier look on where it's common and where it's not. So it was a little bit hard to compare each cities by looking at the graph. So what this person did was create a table, data frame, and we can have overall glance. So it will be good for us if we could. Olympic looks familiar because Koreatown is in the Olympic Street. I'm not really sure how this data set counted like how far it reached, but Olympic is important for us, especially the Koreans and the North Hollywood, West LA, Wilshire is also important. So if we were doing this, we could have a closer look at these streets specifically, or if you want to just do the overall glance, then this will be just fine. So among the most common crimes by cities, the following crimes occurred across all cities. The traffic drive number, battery, simple assault, vehicle is stolen, and burglary from vehicle. So yeah, traffic, all true. Simple assault, all true. I guess it really depends on how you define the simple assault. I guess like all minor battery will be just put in there. I guess that's why it's common here. Vehicle stolen. Yep. And steal vehicles anywhere. Deadly weapon. So it's false here. It's true in Olympic. That's not good. West LA, kind of richer area. So I guess that's why it's false here. Maybe not. Wilshire also kind of interesting. That is true in Olympic, but false in Wilshire. Anything else? Burglary from vehicle, we did that. No, we didn't. Okay. So people break into the cars anywhere. Doesn't matter the cities. Except for the 77th Street, the petty theft occurred across all city. Petty shoplifting, however, was the least common crime. Okay. I'm guessing that this petty shoplifting, it's kind of different nowadays. I think there will be a lot more shoplifting. Reported crime. We note from the data set that there are two columns that focuses on crime occurrence and reported. How many instances weren't reported on the same day? Okay, so they reported and date occurred. We're gonna use these two to date time. So this is important because although the format that we've seen looks like a date, it's always important to check that which type this data set is. So this person wanted to make sure that we put the to date time, because if we want to see if the instances was reported on the same day, that we need to compare them, or we need to compare them. But if it's in a if it's not in date, if it's in text, then it's gonna be hard for us to compare. So they reported, they occurred, so it's pulled out it. And then crime reported delay is when the crime data date reported is not equals to the crime data. Okay, so if there's a gap in those two, then it's not reported on the same day. So we're gonna print the crime report delay and the length of the crime data. Yeah, we want to find the percentages, and then we doing the delay dot head. So about 50% was not reported in the same day. Okay, we're looking we see that our code was right, but some of the data points seems to be weird because the date occurred is later than they reported. Okay. But some of these reported occurred. Kind of funny. I guess we need to have a look at the definition, but this seems a little bit weird. So almost half of all crimes reported a few days later. Upon looking at the result, we notice some of the crimes has been reported before even occurring. Yeah, so that seems weird. For now, let's assume that whichever date occurred first is when the crime was committed. So it's always difficult to get the right data. There's a lot of flaws in there. So whenever you're doing the data analysis or sometimes some kind of works with the data, you need to check for any flaws, any missing values. So data cleaning, it always takes the most time. So I'd like to ask the following questions. What was the longest time it took to report the crime, and what was the average report date? Delays, ABS, the absolute value of the crime report delay, they reported, minus the crime report delay, date occurred. So we could do the minus because we change it to date time. If it was not, this will cause a problem and you won't get a meaningful result. So because they did the absolute value, because some of them report date was after before the current date. So assuming that whichever occurred first was, so it's doing the absolute value and delays that describe count. The mean is 14 days. Wow. The standard deviation is 57 days. So on average, it took 14 days to report the incident. Minimum was 1 days. Minimum was 1 days. That means there were no cases that the occurrence was the report was made on that day. Oh, so this only did the delay one, so that makes sense. And 74% is 5 days, and the max was 1,422 days. Okay. The longest time it took to report a crime was almost 4 years. The average amount of time is just 14 days. Okay. That seems 4 years. That's a lot of time. Okay, the graphing the crime numbers. Let's now chronologically graph the number of crimes reported and occurred. The crime data, date occurred, value counts, the sort index, dot plot, plt dot title, and time, number of crimes, show And the crime data reported, same graph. Now it's wanna plot with the color red, so we can see the difference. And then it's gonna plot it and then show. It would have been better if kind of did on the same graph. Did I run this everything? I run this, run that too. Okay, so crimes occurred, that was 12, number of crimes. Okay, that kind of reached its peak over here. Then the 14, as the time goes. This looks like the very start of 2012 here. And then it goes into the middle. And then it reaches this peak. And then goes up, and 13, it reaches peak. Okay, so this graph is also kind of interesting that they reach its peak in the new year over here. And then it reached its second peak in the summer, but it looks different here. But we can see it in common that the beginning of the year it occurs a lot. Here too in 2014. Here and then 2015 over here. And then 2016 over here too. We don't have a 17 yet, but we assume if we have a guess, then it's gonna peak again. But it's slightly decreasing, so I guess it'll be a little bit less than that. Reported here. Something big has happened in 14 and something big has happened in 2016. So what happened here? So only we can do is guess why this might have happened. But for me right now, I don't really remember what happened those days. But we can always look it up in the news. Interesting, whereas crime occurrence experiences periods of volatility. So reported the tail. So take note that crime reported and occurred graphs contain a sharp decline by the end of 2015. What day was that? Value count dot tail, last one. And let's see, I reported one here, and then occurred was on December 2nd and December 3rd. Okay, so the date was around the time of the San Bernardino attack. We have to be aware that according to LAPD, data is missing around this time period. Could it be possible that data was lost due to the shock to reactions of the attack? Okay, so this person knew what happened in 2015. I haven't heard of this incident. Maybe they attacked the police office, and then I'm not so sure. If you're interested, you can look it up about it. And then the crime status is descending here. Okay, this all squeezed together. Invest count, adult address, and adult other. So over 4/5 of the crimes are under investigation. This is admissible since Los Angeles has a high crime rate. What status is most associated with the crime type? So for status in crime data, valid counts that keys. For status in crime data, dot value counts dot keys. Okay. So we by now know that if you do the value counts, it gives the keys and values. And then status, and then temporary crime data, status dot descending order, description equals status. So if it's the same here, then it's gonna be pull out the crime description and the value count. So most crime, so dot format. Now we know what this does. Status and then temp keys. Now we can pretty much do the same one with F string. It will be with F status and then the temp keys. Yeah, so we can see that the F string and the dot format is the same thing. So let's comment out. The most common crime with invest is traffic. Investigation continued, I guess. And the most common with adult, other is very adult arrest is spouse abuse. Okay, juvenile arrest is battery, simple assault, juvenile other same unknown traffic, and I'm not sure what UNK is. We can also look it up. Okay, let's have a quick break unless anyone has any questions so far. No?
Um,
Uh,
I was in a breakout room with Julia because her Jupyter notebook wasn't installing. Could you help us during the break? If
Yeah, okay. All right. So everyone else can have a break and come back in 8:15. So 10-minute break.
And then Julia, could you share your screen like last time?
I think I need to cut my screen. Yep.
Thank you. Yeah, Julia, whenever you're ready. So basically, we were going to the terminal, but then it
Uh-huh.
kept saying that the pip or the PIP that we're supposed to do the environment on isn't
Uh-huh.
inside her computer. So then I was trying to troubleshoot, but like it didn't work. So
So this is the beginning of the process. I
yeah,
mean,
so uh-huh.
okay.
Because it worked for Daniel, but then it kept saying that the pip is not recognized as an internal or external command. So then I didn't know what to do.
Hmm. Okay.
Could ask chat.
Yeah, I haven't tried this way of downloading Jupyter. Let me see. Maybe
How do you usually download it?
I download like a download file through um okay, what I did was um are you using this are you using Windows or a Mac?
You're using Windows.
Windows, okay. I I downloaded with Anaconda first and then downloaded Jupyter Notebook.
Okay, you did Anaconda. Okay, okay. Wait,
Okay.
Julia, I'm gonna send you something in your chat. Can you try copying that in for me?
Yeah.
Um,
Okay. I think it worked. Okay. Yes, this is final location. Can you go to your quick search for me, Julia? You know the one at the bottom of the screen, the searching at the bottom. Yeah. Can you search up environment variables? Variables, Variables. Can you open that? No, the where it says open on the right.
yep, right there.
Yeah. Path. Okay, hold on. Search. Click environment under system variables. Path. Click edit. Paste the path. Find the location. Python. Can you check if there's anything called Python in the system variables? Like scroll down. If you scroll down, yeah. Is there a Python? Because then we might have to do Anaconda, like me and Sung teacher said. Okay. Me and Sung teacher, can you explain to her how you use Anaconda to do it?
Mhm.
Because I think that's how I did it last year, but then
Uh-huh.
I got the PIP to work, so I didn't have to do that the second time.
Okay, let me try something first. Just getting the right system variable. Try the start app data. Can you type that in your command prompts? The start %, app data %. You can close that for now. I mean that the environment variable, yeah. Open up your command prompt.
The black screen.
Yeah, and then
Yeah.
type what I did in the chat. Okay, let's see. Go to the app data on the top of your path. Yeah. Go to local. Go to programs. Try to find programs. Yeah, over there. P programs. Yeah. Go to okay. Did you install Python?
I checked it and it said that Python was there.
Okay.
We can double check though. Because here, let me send the
Go to quick search and try typing on Python. I think
yeah.
there is a Python over there. But Python. Okay, it is installed. Do the open file location for me. No, the file location, yeah. Okay, now it's not showing up again. Yeah. Yep, that one. Okay, it's in a Microsoft. Yeah, I'm not so sure about this one. Let's just try downloading the Anaconda. I shared the link to Anaconda site. Yeah, do the free download up there. Yeah. If you download that and then install it and then open it up, it's gonna have a Jupyter notebook over there. Let me see. Okay, was it downloaded or?
Okay. Minsan teacher, I'll be in a breakout room with Julia since class is
Mhm.
gonna start again, and then if something's
Okay,
up, I'll come back.
all right. Okay.
And then Daniel, the breakout room message is gonna go to you. Just don't join, okay?
Mm. Okay, is everyone back from the break? All right, so we did a quick look at the code over here and then did a thorough analysis of it, I'm pretty sure you can do further analysis on this. Like we said, we could try to investigate on the reason why always the start of the year, or is it end? I guess it starts and the end. Not sure about exact here. It might be the end of the year. So why this happens? What happened to 2015? Is it really the San Bernardino attack? Let me quickly type up San Bernardino attack shooting case armed weapon on community members. Okay, it was just shooting, not directly to the police office, but they said this is missing around this time period. So that might be the reason why it's started shrinking from 2014. But 2016 and 2016 was also had a decrease in the number of crimes. So that could be an interesting point to have a look at. And then anything curious or interesting that you guys thought while going over this, or is there anything that you guys wanted to mention about? No? Okay, so it's always good to have a talk with your fellow teammates. So it might not be correct one because analysis is always about thoughts, analysis, getting proofs. Is it correct or not? It always starts with that. And something interesting is that as you're talking with your friends or teammates about it, you get new ideas. So something pops out. Your teammates might have a different opinion as you are talking about it. You get your something new. You can get something new while you're talking about it. And um then so this was written in like long time ago too, so there's much more graphing options for you, much more analysis tools that you can use. I'm pretty sure it was mentioned in your first week Python classes that Matplotlib is just the basic graphings. You can always get your better graphing tools too. And nowadays, there's lots of AI tools that you can use while you're coding. So it's really good to know what each of these lines of codes are talking about. Is really good for you to understand what it does. Otherwise, it will be hard to fix to get what you really want. And then one of the, let me show you first. Okay, so show you. Nice. Does everyone see my so this is an app called a Cursor. Am I sharing the way? Yeah. So what this does is that you can directly chat with AI. And let's try. I don't know if it really works with the Jupyter Notebook file. Let's see. So everything else is just the same with Jupyter Notebook or Visual Studio Code, but this one has a feature that you can talk to with the AI. But I think my full version has ended, so I wanted to show you how good this is. But I think there's a problem running it with the Jupyter Notebook file. Never mind. So yeah, have a look at do a little bit search on thing called Cursor. I'll write the name in the chat. So what it does is you can, if you're using a ChatGPT, the problem is if the code gets too long, the GPT has hard time understanding it. Also, data import is also a problem using an AI, but this one just talks directly with the file over here. So it reads the result, it reads the file too. So you can do an AI chat and then it can code for you, it will do for you. But the most important part is that you need to understand what it does. So you guys need to brush up your coding skills and then try as much as you can. I mean, if you can write it on your own, it's much better. But I think right nowadays in Visual Studio, so in the industries too, they use a lot of AIs to code for us. So it really would be helpful if you could utilize it as much as you can. I wanted to talk about something. Yeah, so in the past programs, we also we instead of the projects that we are going to do this year, we did like a data analysis, data science projects too. But in this program, we're doing a little bit more difficult, a little bit more interesting, and a real world example, so you won't have a chance right now. But if you go into your Kaggle, just like this, if you go into your Kaggle, if you go into the data sets, there are lots of interesting data sets that you can go into. So all data sets, behavior data, vehicle specs, salaries, there's salaries. Some of them are not very good use, but a lot of interesting data sets are there. And here, trending YouTube video statistics, computer science, computer vision, NLP. So NLP, natural language processing, that I mentioned in our previous lecture. It's good for you to work on too. So best advice is try like simple ones. So to be honest, the one we did is not that complex analysis. What it does is just like preliminary analysis. Show me this, show me that. So just play around with it. Spend some time coding. AI might be a good way to start something, like give me an idea on what I should be looking for. So as you're working on it, you will find something more interesting. Like we did together today. As we were looking at it, we could find some interesting points. Like, okay, so from 2014, it got a great decrease. And then in some cities, this happens, in some cities that happens. Oh, I'm interested in Koreatown, so I'll be looking more into Olympic Street and Wilshire Street. That's important too. And the way I feel is you need to have an idea on what you want to do. So just like the true and false, the data frame that this person, the one we looked at, created, you wouldn't know how to do that if you have no idea of what it is. So have as much experience as you want with various data sets. And then if you go into, I don't know if someone did here, but you can see other people's code. If you go into the data set and just pick one or do computer science, it was updated 16 days ago, but a lot of people, they discuss about it, support it. So people discuss each other, what should we do about this? I did this, what's your opinion? And you can have a look at their codes too. So books, data sets, linear regression model. So we talked about regression model too. So it will be an interesting look with their AI. So this person used this AI tool. Okay, so I haven't heard about this AI, but is it that helpful? Then we can also have a look at these. So you earn a lot from other people. So just like we did today, just go through these, try to understand what this person trying to do. It's always good just by copying this person, trying to do one step by step. We're not doing anything benefits from this, so we can just try to copy, mimic what this person has done. Okay, so there's a heat map. We showed this correlation heat map too. And then the pair plot is just pairing with each features and then see how it's done. And then distribution. So these people do their analysis with so there's a sklearn model selection, linear regression, and then the R-square score that you will learn when you do your statistics course. Yeah, exactly the same. X train, X test, Y train, Y test, and train test split. Then create the model, and then we fit X train and Y train, and then we predict with the X test. So exactly what we did in our Tuesday's class. So only I mean, doing the machine learning in this level is not that difficult. Only thing is that you will need to understand what it does and then how it's been done. So that's the hard part of machine learning too. Nowadays, all these libraries and stuff help us to perform the machine learning, but understanding is a different part. So try to do a research as much as you want. Try to understand what these do. And then, I mean, this project, I would say this is a project. This project will only take about like a few hours if you know what you're doing. So that could really help you in the future aspects. And then yeah, this is something different. It's TensorFlow. That's something different. Recommendations, books, data sets. So really interesting by looking at other people, what they think. The Seaborn is prettier look of the Matplotlib. Let's have a look at the result. Yeah, a little bit more colorful, something like that. I don't think this is a good way of representing things. So just looking at this, what would you have done? I would have like smaller X labels over here, a smaller axis so we can have a look at what it is. I will just cut it by 10 and you have a better idea on what not to do and what to do. And yeah, all these people do the same thing. Linear regression, maybe this person copied from the one that we just saw in the previous, or you can just, or he copied him, or that person copied him. But all the code's the same because, like I mentioned, this exact code is provided in the sklearn webpage. So try to have a look at it. X, Y, DF, they're all the same. Getting the accuracy is always the same. So get more experience with it, get more trials with it. So it really gets easier for you as you practice. There are a lot more. There's the models that you can use, but this is a higher level, so I don't think this is good for now. Or you can just follow the competitions over here. So Titanic, like I said, this is a very famous one that you can start with. There's lots of participants over here, and I think there's already like, yeah, one. So they're already scoring. So this one doesn't really have a meaning on the competitions not right now because it's been too old and then people know what they're doing already. So there's, yeah, there have been notebooks, tutorials, technique competitions, decision forests, and there's all these people uses variety of machine learning techniques, and yeah, I think this will be a good way to start too. And then our projects that you'll be doing from next week is also very good example too. Professor, are you going to mention them today or are they gonna have a different time
Yeah,
next
so
week?
I'm gonna send an email to the student about the hackathon, the link, and then once they are registered and then using the emails, and then we will send the tutorials, and then also I'm gonna provide some the learning materials.
Okay, so yeah, that's gonna happen once Professor sends you the link, and then
Yep. So yep, I think it's pretty much done, right?
right, yep.
So yeah, the student, if you have any questions, you can ask now. And then I'm gonna provide some separate link, but uh, yeah, the Python. If you understand some basics of Python, and then there are something the modules and the packages and libraries, and then lots of solutions are already there. So the most important thing is how actually you can use such modules. So. I'm gonna send some extra some studying the materials, and then yeah by next week, yeah please study that part. Okay, how to use the modules in Python. Any other questions? No. All right. So then yeah let's just stop here today, and thank you Minsang
Okay,
for the teaching, and then yeah please check your email maybe tomorrow. Okay. All right. Okay. Thank you.
Thank
thank
you.
you.
Okay. See you.
Julia, were you able to download?